Welcome back to computer science. Yesterday we were in a unit on nested dictionaries. A nested dictionary is a dictionary within another dictionary, right? You can access access indices within nested dictionaries by using basically sequential or consecutive brackets. So first you'd index like the first dictionary and then index the second dictionary and so on. Can you do that with it? Yeah. It's just not numbers, right? It's keys. Key first dictionary, key second dictionary, and so on. Okay. And then we learned we got a formal definition of data structure, which is just a way to organize data logically, right? Nested dictionary is a dictionary within another dictionary. We can use consecutive sets of brackets to index in nested dictionaries, and then data structure, a method of organizing data in a logical and coherent fashion. All right, I'm gonna jump back in and continue learning. I'll be back to call what I learned in a little bit. All right, so I finished the dictionaries, final unit on nested dictionaries and the dictionary lecture overall. I started lecture 27, which is the second to last lecture of the semester, which is on files. And this first unit that I started is on reading files. So the function open, built-in function, will open up or will create a file object. And this is assuming that a text file exists, like that you're basically calling as an argument. The argument is the text file itself, but it's actually more specifically the path to that text file. All right. So then we've got a method .read, which will basically turn the contents of the file into a single string. Read lines is another method, but this one will actually create or return a list of strings, each string being one of the lines from the file. And then read line, or actually for both read and read lines, they both will take one argument. This argument being the number of bytes you want to read from the file. And they also both, there's something else they both do. I forgot now. File.close. Oh yeah, no. Read lines and read will both read or process up until the end of the file, EOF. And then read line will read the file one line at a time, return one line at a time. This can be helpful when files are enormous, especially compared to memory size. File.close, this is a method that will, or .close, .read lines, .read line, .close will basically close the file, meaning that you can't read or write after that close. Maybe you can open it up again though. All right, reading files. Open function, built-in function creates a file object, assuming a text file such as myfile.txt exists, takes a single argument, which is the path to the file. File.close closes the file, so after which you can't read or write to the file anymore. File.read returns the file contents as a string. File.readLines returns a list of strings in which each string is a line from the file. File.readLine will return a single line at a time, can be useful for very large files. Read file or read and read lines both can take an optional argument to specify the number of bytes to read from the file, as well as both read until the end of the file if bytes is not specified. I'm assuming that read line will also, so for read lines and read line, I think you can probably pass the argument for the number of bytes, and they both, all three will read till end of file if the bytes is either byte specified is either greater than the number of bytes in the file, or there's no specified byte limit. But the textbooks didn't specify that explicitly, but I'm assuming that all three of those do that or have those properties. So that's it for now. That's basically 1 hour knocked out. The goal today is to do another hour and 15 of computer science. So we're going to probably rip through this entire first lecture on files. The last lecture of the semester is on files continued. So, actually, no, we won't do that one next. What we'll do after this files lecture is do the programming projects that are going to be due this Thursday. So that's it for now. Talk to you later today. See ya. Welcome back to computer science. Earlier today, we were working with files. Yeah, open, close, read file, read lines, read line. So I'm going to jump back in, continue learning more about that, and then I'll be back to recall what I learned in a little bit. All right, that was a pretty big session. I finished the unit on file reading. What was the little last note there? Basically iterating over lines is so common that file objects support for blank in blank, and the blanks being for basically line or iterator variable in file object, and that will iterate over the lines. All right, the next then I did a project in the sorting lists unit or lecture. Basically took an input string with space of numbers with spaces in between them, split it, turned those into ints, sorted it, and then printed out the first two, so the smallest two numbers. And then a dictionary basically that was a frequency dictionary, meaning it took it was a function that took in a list of words, basically returned a dictionary for each word had its own key, and if a key appeared once, then it has a value of 1. If it appeared twice, as 2 for its value. Basically, the value depends on the frequency or how many times it appeared in the list. The next unit then that I started was on string writing. Okay. File dot write takes one string input, does not take numerical values. You have to convert those strings first, and then it will write within the file. But in order to write, you have to actually do this thing called you have to specify the mode of the file when it is opened. So the mode is specified as the second argument of an open function, and it can be R in quotes, A in quotes, or W in quotes. R is read only. You will not be able to write, and if the file isn't found, it throws an error. That's also the default mode. So if you don't specify a mode, it will be R. W is write, essentially mode. You can't read it, but you can write, and it will overwrite the contents of the file. And if the file is not found, it will create a new file rather than throwing an error. A is append. It doesn't allow you to read, but again, if the file isn't found, it will create a new file. And rather than overwriting content, when you write, it will append to the file, the end of the file. And then there's also, you can add a plus sign behind R, W, or A, and these are updating modes. And so I don't know what R plus does. I think it allows you to write. I think R plus and W plus are essentially the same. They both let you read and write at the same time. A plus, though, allows you to append and read at the same time. So those are the updating modes. And then buffer. So the interpreter buffers between basically writing and storing that in the hard disk. Basically, when you're writing into a file, it goes into a buffer first before to actually go into the text file. And so the default basically flush or default buffer, I should say, is per line. So if you write half a line, it will be stored in buffer until it's like a new line space is sent, or the line fills up and it goes to the next line. Then that whole line will flush into the file itself or go into a file. Okay, file object support for iterating variable / line in file. All right, writing files. File.write writes a string argument to a file, only accepts string arguments. Good. Mode indicates how file is opened. Second argument in a call to open function. Default mode is R. R allows for reading. If file is missing, it will throw an error. W opens the file for writing. If file is missing, a new file is created. Contents of an existing file are overwritten. Contents of an existing file are overwritten. Good. A is append. Append file or append mode. It creates a new file if file isn't found. No overwriting, only appending. Can add a plus sign at the end of a mode, such as R plus, W plus, A plus. Update mode, not updating mode, update mode. Allows for both reading and writing. Output buffer. Default is line buffered. So the output, or I should say first, output to a file is buffered by the interpreter before being written to the hard disk. Okay. That's it for now. That was an extra long session. I'll be back for one more session to finish out week, 14? Maybe 14. So, yeah, I think we're going to start week 15 tomorrow, which is crazy, but the semester's pretty much just about over. So, that's it for now. Talk to you later today. All right. The final session of computer science for today. This was a long day. This will be over 2.5 hours for today. So anyway, the plan is to just do programs for the session because I've done enough notes, I think, for today. Earlier, before another break, we were doing, modes, files, yeah, writing, modes, updated modes, and buffer. All right, now I'm going to do some programs. So, talk to you in a bit. All right, I just finished up multiple programs. The last one I was working on basically takes a string of words and prints out each word one by one. And after that, word, space, the frequency of that word in the string, case insensitive, and then new line, next word in the sentence or the string, space, frequency of that word, case insensitive, next. So that was that program. I'm not remembering the other programs. Oh, yeah, one of them was Scrabble. So basically, you have a dictionary given with all the different values for each letter of a Scrabble word, and then you need to take an input and then output how many points it would be for Scrabble. And then another one took a string, is a function that took a string input, basically used a for loop to determine if that list was sorted in descending order. If it was, it returned true. If it was not, it returned false. I think those are the three programs. I think I just did three. So, um, all that to say, we are pretty far ahead of schedule now. We should be like um, maybe done with everything by tomorrow. So we'll be like four days ahead of schedule. Everything due by Thursday. So, um, yeah, I'm good for today. I'm gonna call it there. That was a long day. So talk to you tomorrow. See you.